Well, good afternoon, everybody. Actually, the team sport is in reverse order. So I am Sumit Verdi with VMware, part of the Telco NFV business unit. So let me start out with a little bit of an introduction on this technical track on service assurance, and then I'll hand it over to my colleague Rudy, who will drive us a little bit deeper into the technology. So then let me start by first of all basically re-echoing what we've been hearing throughout this conference about the shift in the cloud computing space, more specifically with the networking and the hybrid clouds. We've seen kind of the traditional telco core cloud, which is essentially sort of going through its transformation and kind of evolving from its traditional incarnations to more virtualization, based realizations. And moreover, as we're starting to see also is this, now the proliferation of this cloud kind of deeper into the edges, essentially sort of acting as an enabler for 5G technologies and essentially sort of capitalizing on a whole plethora of use cases we've actually heard throughout the conference so far. And last but not least is again, kind of a further, push of these clouds into what, I term the device edge. And the device edge, pretty much kind of personifies itself, the classic universal CPE kind of scenarios, and more also we're hearing about the IoT different gateways. So what does this actually mean from a service assurance, from an operational intelligence perspective, right? So with 5G, we're essentially going to start seeing the emergence of a completely different architecture with a CUPS-based approach with disaggregation, essentially sort of now providing service capabilities in a more distributed landscape. Needless to say, I think challenges around issue isolation and root cause analysis are going to be even further more complex than what they used to be. Within these cloud environments, capitalizing on some of these, on the virtualization technologies and so forth, the need for proactive optimization is going to be really imperative. As such, the service assurance capabilities, its timeliness, real timeliness, is really going to be really critical. Not just from an infrastructure perspective also, but sort of trying to take a look at kind of the underlying transports and actually looking at the services tier on top of that as well. We've heard a lot about containers this afternoon, right? So as with traditional VM-based VNFs as well, containerization is also on the forefront with control plane functions, basically more on the core cloud side and kind of more edge-based applications, basically sitting at the device edge and at the telco edge kind of layers. Your planning and your workload placements, right, ever so more critical, right? They're no longer static environments, and you really need to make real-time decisions in terms of, utilization consumption, leveraging that information to try and actually figure out where is the right placement for my workloads. Even more so also kind of dynamic instantiation of workloads as well. And last but not least is the service orchestration piece, right? How do you basically sort of orchestrate across these completely distributed clouds? So I think this probably slide comes as a no surprise to most of you folks, specifically within the CSP space as well, is around the cross-tier correlation challenge, right? Services are not just delivered by software applications, right? It's a composition across various components within your network stack. So traditionally, what has actually been happening, right? If I actually take a look at each of these horizontal bars over here, there is different bespoke assurance solutions that actually address the application, whether it's an IMS application or an EPC. You have specific solutions for that space, and likewise, whether you're looking at the RAN space on the fixed or the wireless side, and so on, right? I can keep going on, but you basically got these kind of very kind of vertical-based NetOps solutions. So how do you basically kind of, complement not only that underpinning kind of the infrastructure and the application and the delivery stack, along with, how do you basically kind of take a look at this more from a horizontal plane perspective and provide that turnkey service assurance that meets all of the considerations I discussed previously. So kind of mapping kind of what we all look at, from, as an operations person, as a planner, right? You basically take a look at your physical infrastructure, your optical layers, and your networking stacks and so forth. Really mapping that into kind of the next generation service delivery chains that are, of course, underpinned by the distributed cloud topologies that are basically talked about. With NFVI-based virtualization layers and the applications, both containerized and traditional VM-based applications, kind of trying to basically evolve and transform these networks and these clouds to deliver your next generation services. So at VMware, we've actually addressed this problem statement across this entire service delivery domain with a combination of various solutions and components that essentially span this entire service domain stack to basically sort of provide that assurance umbrella from basic performance monitoring all the way to doing proactive and predictive optimizations. So, looking at it basically from a virtualization stack, we basically address the compute and the storage and the networking and the security at the virtualization layer, in addition to essentially looking at kind of the underpinning physical network. And Rudy will actually go into more details when we talk about these different components. And last but not least, right, logs are still our best friend. I don't think we ever stop kind of scraping logs. And so as essentially sort of having a capability to be able to kind of have a central data warehouse and be able to scrape across all of these different unstructured processing across these different delivery chains, I think is also a key component of the value proposition. So as a key fundamental kind of tenet for service assurance, kind of, looking at it across from a capability matrix perspective, I think just to kind of recap over here, I think we will continue to see, and needless to say, networks will be a hybrid composition of both virtual and physical environments for a very long time, right? How do I do basically dynamic service discovery? How do I actually do the cross-correlation across these environments as the operators in the industry basically go through this transformation? Application monitoring, again, is critical, right? You never receive a phone call from a customer that says, hey, did you know your CPU is running hot, right? It's always, hey, I've got a problem with XYZ service, and you need some way to be able to map your service and the issues associated with it all the way down into the, the areas that are actually impacting the performance of the services. Being able to isolate, kind of basically do a root cause on the services and the availability also, I think, being a critical component. And last but not least, I think I touched upon the performance and the SLA. As we basically start getting into these dynamic environments where your workloads are no longer static and you're essentially sort of looking at complete living networks, right? Your workloads are moving, your infrastructure is dynamically optimizing and so forth. How do you stay abreast of all of that stuff and essentially still kind of continue to deliver that SLA? At the guarantees that you've actually promised. And last but not least, right, configuration management, right? Sometimes I like to even call it the fat fingering effect, right, where things have gone haywire and you don't know why. So that essentially sort of are the various, various characteristics of the service assurance. I'll hand it off to Rudy at this point in time to basically drive us through next level of technical details here. Thank you.
So let's first have a look what we have on the truck. So we have VROPS. Most of you, I guess, are familiar with VROPS. It's all about monitoring the NFVI. It focuses on compute and storage. We have Network Insights, Verdi, as we call it. So that really focuses on the network overlay. It monitors a small part of the underlay as well, but it really focuses on monitoring VXLANs, VTEPs, and also analyzes traffic flows to see how traffic flows from one VM to the other. We use that also to build our firewall rules, which you can then push out to virtual firewalls. So that's the Network Insight piece. It was the Arkin acquisition, in case you're wondering. Then we have Smarts, which is a new acquisition, so it was acquired last month. Smarts is all, most of you are probably not familiar with Smarts. Smarts is all about trying to build the end-to-end picture of an infrastructure. So whether that is a transmission infrastructure or a mobile infrastructure or just an enterprise infrastructure, it's all about building all the relationships in the infrastructure, moving up to the software layers. We'll talk more about Smarts in a moment. We also, to Sumit's point, logs are still our best friend. So Log Insight is a tool that can capture logs from a whole wide range of sources and put the log events into context. So it is definitely something you might want to look into. Now, what is important, you can use these tools in isolation, but of course they work better when you combine them and when they work in concert. So when they work in concert, we can actually identify, so we can discover the entire infrastructure. And as I mentioned before, it's not just the NFVI, it's really the end-to-end infrastructure. We can then build the topology or stitch the topology together because we build all these relationships really from the network infrastructure all the way up to our VNFs. We can do correlation. So if there is a problem with a VNF, it might be a performance issue, but that performance issue might be because there's a routing issue in your infrastructure. Because we build all these relationships, we're actually able to do that correlation. And that is really important that we as VMware have that capability. We can then, of course, report up to operators using dashboards and reports. What is important, because we do the root cause analysis, it becomes easier to identify issues. So your mean time to identify, your mean time to repair become much smaller. And that's basically, I think, a very important thing to remember. Because we also baseline the infrastructure, so we capture performance metrics and we baseline the performance data, so we know this is normal behavior, so we can also identify what is abnormal behavior. We can identify anomalies, and so we can then hand that off. So if we, for example, see that our performance of a VNF is bad, so what we can do, we can then scale out by just talking to an orchestrator. And that's what you will see on the right-hand side. So we can hand off our information, anything that we monitor, we can hand that off to either an NFV manager or an orchestrator. And now we can, for example, enable or call a Tosca blueprint so that we can spin up additional VMs and so improve performance. So we have that capability within our set of products as well. Now you might wonder, how do we capture all that data? So we have a whole range of collectors on the left-hand side. So we can query SNMP agents, basic stuff. We can process traps and syslog messages, but we can also, for example, take telemetry data. So whether that is streamed in XML or JSON or Google protocol buffers, we can take that data. So instead of us going out every 4 or 5 minutes, we can basically take data in real time as it is produced and act upon that data. We can tap into element managers, so we can tap into Huawei U2000, in Ericsson OSS RC, just to capture all the performance data. Because of course, what is also important to note, we are agentless, so we don't deploy anything. We are non-intrusive, so we just use whatever is available. So that is important to note as well. We, of course, can also tap into the NFV orchestrator or the NFV manager to identify topology, so relationships between VMs, hypervisors, the SDN controller, the SD-WAN controller. So we can tap into all of those as well to identify relationships. The onboarding is, so how do we onboard customers? It's fairly simple, right? So you either discover the infrastructure as a whole or per tenant. So then once we discovered the infrastructure, we will then build specific dashboards per tenant so that tenants can monitor their environment. What is also important is we capture basic characteristics once we do the discovery, so we can then immediately identify which sources are overutilized, which sources are underutilized, so we can do capacity management and capacity planning from day one, because of course we capture those basic characteristics. Second step, we start performance monitoring, and as I mentioned before, once you do performance monitoring, you can also start doing baselining and identify what is normal behavior, what is abnormal behavior. And so that is basically what happens between day one and day two. Once you identify this is abnormal behavior, so I'm deviating way too much from my baseline, we can then take corrective actions. So we can do auto remediation. We can then call an orchestration engine to just spin up additional VMs, for example, or make a change on a network device, because we have that ability as well. So we can also reconfigure network devices as part of our assurance suite. So that's basically the onboarding. What is important when we talk about we need to monitor VNFs and we need to monitor our SDN layer, it's really important that you understand, to Sumit's point, it's not just about monitoring the piece in the middle, because your service is actually provided by this entire infrastructure. So if you have a mobile service, you need to be able to monitor that as well. And with our assurance suite, we can monitor 3G, so we can monitor Node Bs, we can monitor GGSNs, SGSNs, we can monitor 4G LTE, so we can monitor eNode Bs, we can monitor MMEs, PGWs. We can monitor the MPLS network, so we can monitor IPVPNs, but also multicast VPNs. We can monitor eVPNs. We can monitor the control plane as well, so we can do OSPF BGP monitoring. Of course, we can monitor the NFVI. I mentioned that already, by tapping into the SDN controllers, the SD-WAN controllers, by tapping into orchestrators and NFV managers. And we also can monitor IPsec tunnels, for example. So with our assurance suite, we are actually able to monitor the entire stack. And I think that's really important to emphasize, that if people talk about we need to monitor SDN and NFV, it's much more than just the part in the middle. This is a functional description of our assurance suite. This is just all the building blocks. So we have a mediation layer, which is basically all our collectors. This is the layer that talks to all the different devices, the element managers. We then have a discovery service that will stitch the topology together, will store it in a graph database. We have data models that basically describe the relationships we are looking for. And because we then have that data model in place, we populated it, we can now actually start doing the root cause analysis. And again, as I mentioned before, we can present this up to dashboards and all kinds of reports. We can hand it off to our Mano layer. That's a possibility as well. And what I really want to emphasize, even if you use your own reporting engine, we have a whole range of APIs, REST APIs, web services APIs, we have Perl, Java APIs. So we can also stream all the data we collect to a Kafka bus, so you can subscribe to a topic on Kafka. Our events are stored in Elasticsearch, so you can also just use Kibana if you want to look at our events. And what I wanted to show here was just, this is an example of, for example, where we took our API, collected data from performance data from our solution, stored it in an InfluxDB, and then used Grafana to build some dashboards. And the same goes for our topology. Our topology services, you can just query your topology services. This is an example where we use Bootstrap and Angular and NextUI, JavaScript, to just build a topology map, which we pulled from our system. So that's what I have. So just, I think, to recap, it's important to know that VMware has this assurance capability across the stack. So it's not just we monitor our own infrastructure, we are vendor agnostic, and we can monitor the end-to-end stack.
We have about 1 minute in the timeline for questions. If there's anybody with something they like. Otherwise, I know these guys are around
Right.
So happy for you starting now. Nice job. Thanks, guys.
Thank you.